Okay, in 1.4, we're going to talk about types of functions. Definition, intercepts are the points where a graph crosses the coordinate axes. An x-intercept is an x value where the graph crosses the x-axis. A y-intercept is a y value where the graph crosses the y-axis. For example, suppose that we have the line y equals negative 2x plus 5. Okay, if we want to find the intercepts first, the x-intercepts, we need to let y be 0 and solve for x. So when y is 0, 0 is equal to negative 2x plus 5. Add 2x, divide by 2, x is equal to 5 halves. And to find the y-intercepts, we need to let x be 0. When x is 0, we just have y equal 5. So 5 halves 0, and 0, 5 are the two intercepts. Now these would be 2 points on a line. We're drawing a line, y equal mx plus b. And the slope of the line is negative 2. And the y-intercept is at 0, 5. Definition, the slope m of a line containing the points x1, x2, x1, y1, and x2, y2 is m equals y2 minus y1 divided by x2 minus x1. For example, suppose that we had the line with the points negative 1, 1 and 4, 3 on it. Okay, if we want to find the slope of the line, use this formula right here. So the difference in the y values, x1 is negative 1, x2 is 4, y1 is 1, y2 is 3. So y2 minus y1 would be 3 minus 1 divided by x2 minus x1 be 4 minus negative 1. Negative 2/5 is the slope. So here's these 2 points, negative 1, 1 and 4, 3. And a positive slope means that you're slanted in the positive direction. A negative slope means that you're slanted in the negative direction. And with a negative slope, that means that you can construct a capital N for a negative using the line. So I've got a positive slope. I want to rise over run. Rise is 2 units. Run is 5 units. So if I rise up 2 and then run to the right 5, I'd run to the left if this was a negative. So now a linear function is a function of the form f of x equal mx plus b, where m and b are real numbers. M is the slope and b is the y-intercept. The domain of a linear function is all real numbers. So for example, suppose that we have the function f of x equal negative 2/3 x plus 1. Okay, the first thing that I notice is the y-intercept is at 0, 1, and the slope is a negative 2/3. I know I'm going to be drawing a line slanted in the negative direction. The slope is negative 2/3, so I need to go up 2 and to the right 3, or down 2 and to the left 3. 0, 1 is on the graph, so the y-intercept is at 1, or 0, the point 0, 1. The x-intercept is found by letting y be 0 and solving for x. So when y is 0 and you solve for x, add 2/3 and then 2/3 x equal 1 means that x is equal to 3 halves. So x would be 3 halves 0. 3 halves is right in between 1 and 2. Of course, I don't want to have the line cross at 1, 0 or 2, 0. The 0 is the same as the x-intercept. And that number is 3 halves. Okay? Here's an example. The cost C to rent a small moving truck and drive it X miles is C equals 0.15x plus 19.95. What is the domain of C? Well, because C represents a line, and the line can be any number, then the only other thing with the line is that now 0 is okay. Anything bigger than 0 is okay. Anything negative makes no sense, since x is the amount of miles driven. You can't drive a car in negative miles. Interpret the slope and the y-intercept. The slope m is 0.15, and that's a dollar amount. Okay, 15 cents per mile would be the slope. The y-intercept is 19.95. That's again a dollar amount, and that would be the rental fee. In order to rent the moving truck and drive it X miles is going to cost you $19.95 just to get the truck in the first place. So suppose that we want to find C of 50. Well, C of 50 means that I'd replace 50 with X and simplify. Okay, 0.15 times 50 is 7.5 plus 19.95. That gives me 27.45 as the cost that I would pay if I were to rent the truck and drive it 50 miles. Okay. A horizontal line is given by y at y equals b, and y and f of x mean the same thing. And a horizontal line has a slope of 0. A vertical line is given by x equals a and has an undefined slope. Okay. Why didn't I write f of x for vertical lines? Well, a vertical line are not a function. So if I have a vertical line, then I have something that fails the vertical line test. A horizontal line is okay. A horizontal line at y equals 3 or y equals negative 5 or whatever, that's going to be okay, because a horizontal line only passes the vertical line test at one point anywhere. Now suppose that I want to find the slope of a vertical line. Let's do this one, for example. Y equals 3. The slope of y equals 3, and I guess let me first get 2 points that are on this line. If x is 0, y is 3. If x is 3, y is 3. If x is negative 2, y is 3. If x is 4, y is 3. If x is anything, y is always 3. Okay, so x can be anything, and the y value is always 3. 3 minus 3 is 0, and 3 minus 0 is 3. 0 over 3 is 0. So I've plotted these points here, 0, 3, and then 3, 3. X can be anything, and y is always 3. So that means that I'm going to plot a point at a height of 3 units above the x-axis. And the slope for this line is 0, then, like I said. Okay, now in the case of vertical lines, suppose that we have x equal negative 2. A vertical line has an undefined slope. The reason why that is because the slope is calculated here. If I let x be negative 2 and select any y value I want, like y is 1, x is negative 2, y is negative 3, x is negative 2, y can be anything, and x is always going to be negative 2. So change in y over change in x, the difference in the y values, y2 is negative 3, y1 is 1, x2 is negative 2, 1 is negative 2. Negative 2 plus 2 is 0. And that's a problem is because I can't divide by 0. I'm going to have an undefined slope. So a vertical line always has an undefined slope. Here's x equals negative 2. And so here's 2, 1. And here's 2, negative 3. And I said y could be anything. X is always negative 2. Yeah, that slope is undefined. Okay, when we stop right here.